Hi, hello, and welcome to our channel Practicals Learning. This channel is managed by myself, Purushothaman R, and my friend Anirudh Sharma. Please do like, share, and subscribe our channel and keep learning. Before moving to the further topics, so in today's session, we will see a small topic which is very important for competitive exams, but not so important for PUC, but it is important. That is optical activity. So optical activity, what are the terms in this topic? All those things we will learn in this session. The first term related to optical activity is plane polarized light. That is plane polarized light. If a light is made to fall from a source, my light goes in all direction. Light goes in all directions. It goes in all directions when it is passed through a Nicol prism. It is Nicol prism. When it is passed through a Nicol prism, my light will travel only in one direction. That light is called as plane polarized light. So plane polarized light means the light, normal light, which travels in all directions when it is passed through Nicol prism. From that Nicol prism emerges a light which travels only in one direction, and that light is called as plane polarized light. This itself is plane polarized light. Then what is optical activity? Means the substances which can rotate the plane polarized light, which can rotate like this or like this, which can rotate the plane polarized light, are called as optically active substances, and this activity is known as optical activity. The substances which can rotate plane polarized light are called as optically active substances, and this activity is called as optical activity. There are certain terms to define this rotation. They are dextrorotatory and levorotatory. It is V. Levorotatory. What is dextrorotatory? What is levorotatory substances? My substances which rotate this plane polarized light, towards right side, due to its structure, which rotates the plane polarized light towards right, are known as my dextrorotatory substances, and it is denoted by plus. And what is levorotatory? Obviously this is right, means this will be my left. The substances which rotate the plane polarized light towards left are my levorotatory, and they are denoted by minus sign. So this is dextrorotatory substances, levorotatory substances. So next definition that we have to learn is optical isomerism. What is optical isomerism? Is, we all know that isomerism means Isomers are the substances which are same in molecular or structural formula but differ in structure. So this is optical isomer. Here we will study about optical isomerism. What is optical isomerism? Is the dextrorotatory and levorotatory. Just now mentioned, the dextrorotatory and levorotatory of an optically active compound of optically active substances. Optically active substances, dextrorotatory and levorotatory structures are called as optical isomers. Optical isomers, and the phenomenon is called as optical isomerism. What are optical isomers? Optically active compounds, dextrorotatory and levorotatory. If I take a compound A that has structure like this, A and A, this is dextrorotatory, this is levorotatory. For example, I am telling both these are called as optical isomers. Optical isomers. This phenomenon is called as optical isomerism. Yes, and the next definition to be learnt is chirality. Chirality. A simple small example is our hands. Our hands. Objects are molecules which are non-superimposable. My hands are superimposable, but which are non-superimposable are called as chiral molecules. I am taking an object A and its mirror image like it is like this. For example, I am telling it is like this. If it is non-superimposable, if I place this on this, if it is non-superimposable, it is said to be a chiral molecule. It is said to be a chiral molecule. The phenomenon in turn is called as chirality. This is chirality. The next definition to be learned here is asymmetrical molecules. Asymmetrical molecules. What are asymmetrical molecules? We all know what is meant by symmetry, which is same by like this. In terms of chemistry, I am having CCC here. I have Cl like this. I have CH, 2CH3. I have like this. I have Br here, or I have I here like this. The molecule which have an asymmetric center, asymmetric carbon atom, where all groups are different. All groups are different. It is ethyl group, this is chlorine group, this is iodine, it is bromine. All groups are different are called as asymmetrical molecules. Asymmetrical molecules is the molecule which have an asymmetric carbon atom such that all the group or all the atoms attached to the carbon are different, are not same. That itself is my asymmetrical molecules. Then I have next topic to study is enantiomers. What are enantiomers? Many confuse between enantiomers and chiral molecules. Chiral molecules are some substances, but enantiomers are optical isomers. Optical isomers which are non-superimposable, which are non-superimposable, which are non-superimposable mirror images, which are non-superimposable mirror images. They are mirror images. For example, like this I have H, OH, CLI. Simple example I am giving. The mirror image will be like this. Mirror image will be like this. IH, OH, Cl. The mirror image will be like this. But they are non-superimposable. If I take this and if I superimpose it, they will not superimpose. That itself is my enantiomers. This itself is enantiomers. Then next is mixture of these two. I have one molecule and I have two molecule. Second molecule, mixture of these both enantiomers, mixture of enantiomers is called as racemic mixture. Mixture of enantiomers are called as racemic mixture. Mixture, I have got it in a reaction, then this is called as racemic mixture. And one more thing, this might be plus, this might be minus, that is, this might be dextrorotatory, this might be levorotatory. So this two enantiomers, therefore it is racemic mixture. An important question asked in PU board exam is, why are racemic mixture optically inactive? Racemic mixture are always optically inactive because the net rotation, my plus diverts the plane polarized light to right side, my levorotatory tends the light to left side. Both the rotation club up, that plus that clubs up, and the molecule becomes inactive. Both, see, minus into plus makes me minus itself. So itself, both minus and plus, if they are in same solution, then they are optically inactive. Very important question. Why racemic mixture is optically inactive? Because racemic mixture is optically inactive because it is equimolar. That is important. Equimolar mixture of D and L isomer. D and L isomers, the angle of rotation caused by D is cancelled by the angle of rotation of L. Both the rotation cancel each other and they make the racemic mixture optically inactive. This itself is very, very important. The next topic to be learnt here is racemization. This phenomenon, the process of conversion of one enantiomer to another enantiomer, is called as racemization. Plus 2, I want my this thing like this itself, iodine I want at this place only, means I will convert this plus into minus, that is dextrorotatory to levorotatory, or I want molecule like levorotatory to dextrorotatory, then that process is called as racemization. This is racemic mixture. This process will be known as racemization. Then I have two important concepts to be learned here is retention and inversion. Retention and inversion. These topics are very, very important in terms of competitive examinations, but simple definitions will be asked in PU board exams. Now I have my retention and I have my inversion. What is retention? What is inversion? What is retention? If in a chemical reaction the special arrangement of bonds at an asymmetric center remains the same, like this, I have for example I am drawing A, B, C, X. I have a haloalkane like this. I will remove X and I will add Y. So my reaction is carried out without the structural change. They all are there in their same position. My configuration is not changed in the reaction. So therefore, if it is remaining preserved there, my structure is same as in my product and reactant, but I want this one to be changed, then that itself is called as retention. My SN1 mechanism follows retention. What is inversion now? If it reverses to 180 degree, my A and B, that example itself I will take. If it reverses to 180 degree like this, if it reverses to 180 degree, then it is called as inversion. My SN2 mechanism follows this. We had told Walden inversion. So this itself, yeah, inversion. If the structure remains same in the reaction, then it is called as retention. If the structures get inversed to 180 degree, then it is my SN2 reaction, and it is process is called as inversion, and this is retention. Very important. So retention and inversion. Next, the last topic of this optical activity is stereochemistry of SN1 and SN2 reactions. Stereochemistry of, what is, first of all, stereochemistry means? Stereochemistry means the study of chemistry of spatial arrangement of atoms in a compound. My compound is like this arranged, then how they are arranged in space. If I'm taking, this is a simple representation what we are doing, how they are arranged in space, how they will be there in real, all those study will be called as stereochemistry. All those study will be called as stereochemistry. My stereochemistry of SN1 reaction. SN1 reaction. If SN1 reaction, if it is having optically active alkyl halide, I have my optically alkyl halide in SN1 reaction. If it is optically active, then the product will be a racemic mixture. Like my product will form both plus and minus, that is D and L products, if it is optically active, and it accompanies racemization. This itself it is told. So my racemic mixture will be formed like this, A, B, C, D, like this. If it is there, racemic mixture, how my racemic mixture is obtained? The mirror images like this, D, C, B, A, mirror image like this. For example, I am telling you. So stereochemistry of SN1 reaction tells me that if my alkyl halide is optically active, the reaction will accompany racemization, and my product will have both D and L isomers. This is stereochemistry of SN1 reaction. Then SN2 reaction is SN2 reactions. If my optically active alkyl halide is there, then it is accompanied by inversion of the structure. Inversion of the structure, that itself we called it as Walden inversion that day. Inversion of structure. For example, I have my HHX here. My nucleophile attacks it from backside, and my product will be formed like this. So inversion of this, hydrogen goes here, this like this, and here nucleophile attacks it from backside. So this itself is the stereochemistry of SN2 reaction. This takes place through inversion. So this itself, the optical activity, total optical activity and stereochemistry of SN1 and SN2 reactions. We will see some other topics in our coming videos. Thank you.